Hello friends, welcome to Joy of Life. So today we are going to look at another medium level problem from Leetcode. The problem number is 15 and the name of the problem is threesome. So given an integer array nums, return all the triplets num I, num j and num k such that I not equal to j, I not equal to k, j not equals to k. So all of them should be different, right? And num I plus num j plus num k is equals to 0. So we have to find all the triplets where we have this sum 0. Notice that the solution must not contain duplicate triplets. So what it basically says is that you can see over here we have duplicates, right? And we should not use the duplicates. We should avoid the duplicates and come up with the unique result, right? Over here we can see that it's one of the result. This is another result. So since there are -1 twice, so you could have said that I have a result something like this as well, right? But here you can see that the results are duplicate, right? So we are going to avoid them and we are going to come up with only one of them, right? So this one is not a cross, actually this is a tick and this is a cross, right? You can have an empty array wherein you will return an empty array and there is a 0 and 0 cannot contribute to the result. We need a triplet, right? So we should return a list of integers over here, and each of them is one list item, right? These and these. So you have to return it back as a list, right? So yeah, this is the problem all about. We are going to discuss the solution, check on different approaches and come up with the solution. But as I always recommend, do give it a try before you check out my solution, and then you can check my solution. So let's move over to the board and check out the solution. So I've taken the same array over here and we are going to understand this problem. So before we deep dive into the solution for this, let's understand that what we are looking for. So we are looking for three numbers over here from the array, right? So rather, I should say three different numbers, right? They cannot be the same numbers, right? So that is my first constraint over here. And second is sum of the above numbers should be 0. So these are the two constraints. So basically, if we wanted to find three numbers, right? So let's first understand how we can do it for one number that is 0, right? Very simple. So what we can do is we can do a order of n by searching into this array, right? So we traverse over this array in order to identify where we have a 0 and we return that 0, right? And how can we make this better? We can make this better to order of log n, the searching, only when I can sort this array, right? So here I have the array in a sorted way. So what I can get from this is a order of log n, right? From this. And also let's consider that our searching also comes with the overhead, right? So we have a order of n log n. Sorting will take a n log n and we have a log n for the searching part over here, right? So remember over here I'm talking about a single element over here, right? I'm not talking about multiple elements over here. Right, we are just trying to explore our options. We are just trying to see what are the different choices we have. So looking at this graph over here, we have order of n over here and we have a order of n log n, right, over here. So for a single element, we could definitely see that it makes more sense to go with the brute force approach, which is a order of n, right? Now if I extend this problem to two elements, so now let's understand what will be the scenario over here. So if I don't have this array sorted and we need to figure out two numbers whose sum is equals to 0, let's say these are these two numbers over here, I don't have much choice, right? For each element, I have to go ahead and check the rest of the array in order to see that I have the element that I'm looking for or not, right? And what will eventually happen is we will end up having a complexity of order of n square over here, right? For each element, we are going ahead and checking for all the numbers, right? Now coming to this solution over here, what will happen basically over here? So I already have incurred a cost over here, which is a n log n, right? For sorting this array. This is my cost that is fixed, right? And now since my array is sorted, what can I do in order to find out the element, right? So probably since this is sorted, I know that I can have two pointers, right? Over here and over here, and both the edges, right? And what I see is that I know that the number at the left is the smallest and number at the right is the biggest, right? And this is giving me a sum of 3, right? 4 and a -1. So I know I am looking for a 0. So I have to reduce from 3, right? These two points at the left and the right is in two edges, right? So my left cannot go any further left, right? Now what will happen is I know if I increase my left towards the right side, what will happen is I'll start finding bigger number or the same number, right? And what will happen? It will push up the sum, right? Because the values are increasing, right? And if I And for my right, I cannot go any further right because that's the last index. And I know if I go towards my left, I'll start finding values which are equal to or smaller than me, since there are duplicates, right? So I'll start finding smaller numbers. And what I want over here is I have a sum of 3. I want a smaller sum. I'm looking for a sum that is 0. So what I'll do is I will start moving my left side in order to find it, right? And now we got a 2 and a minus 1, right? 2 and a minus 1 will end up having a value of 1. And I know even still I want a smaller number. Again, right can move towards right, but that will increase the value. So right, if move towards the left, will have smaller values. So I move this pointer to the next one. And the value that I got is a 0. So here I know that this is one of the combination where these two can make a sum which is 0, right? And we continue. And as we go over here, we get a sum of minus 1. So this time what we need is a higher number. And in order to get a higher number, I should push my left, right, towards the right side. So I will move this over here, and what I'll get is a minus 1 over here. So there is no chance for me to find any more answers. So the only answer that we have found is here and here, right? So this is how we find for 2. So this operation that we have done in order to find will cost me an order of n, right? Because I am traversing the array. In the worst case, what I'll have is an order of 2n, which is eventually becomes order of n. So your complexity for this algorithm will be n log n plus order of n, right? So n square is somewhere here, n log n is over here, and order of n is over here, right? So definitely this time sorting makes more sense to me, right? If we sort it, we are getting a better performance, right? It's definitely giving us some better result. Now we are going to extend this problem in order to search for the triplet, right? We have seen for the one element, we have seen for two elements, so we have searched for a single, we have searched for a double, and now it's done, we do it for a triplet. So once again, we are going to look at when we have the unsorted array. So what you can do when you have an unsorted array over here and you need to find a triplet, right? So whatever way you might try to do it in an unsorted way, that you pick up the first element, you pick up element by element. So minus 1 is picked up, and what you need is a plus 1 in order to make a 0. And this plus 1 should come from two elements. Picking up this element over here, what you do is you pick the other element, the next element, and then you still look for a plus 1 into the rest of the array, right? Similarly, you take the minus 1 and you take the 1, and then you look for a 0 in rest of the array. And then again you took the minus 1, you take the 2, and what you look for a minus 1 in the rest of the array, right? So you'll basically try to explore all the combinations, right? And what you'll end up doing is you're picking one element, you're picking other element, and you're doing a search on the rest of the array, and you are repeating this again and again. So what we'll end up having over here is an order of n cubed, right? So you'll have 3 nested loops over here in order to find out those combinations, right? With some checks here and there for the duplicate. Again, a very tedious process, right? So what we can do is, if we have the array sorted with the cost n log n, and now I need to find that element, right? So what I can do over here is I can take this element and I can do that order of n searching for the double elements that we have done over here, right? So what will happen is I'll pick this element and I will do a order of n pass, right? So n into, we are doing a n pass. Here what we have done a n into n pass, right? Just because we are sorted, we can just take care of this guy over here. So that will give me a n square, right? So what basically we are talking over here is that we have a minus 1 and we need to get a 1 in order to get a 0. So we can do the same approach that we have done over here, right? We can do it only in this sub-array, right? So what will happen is, first sum that I will get is a 4 minus 1, that is a 3. So I need to reduce value. So what I'll do is I will start moving the pointer to this edge. So again, 2 minus 1, the value I'll get is a 1. And what we are looking for is a 1, right? So I know that minus 1, 2 would be one of my answer. I continue the search over here and we are still looking for a 1. So what we'll be basically doing is we will try to move up the pointers and see that the value has increased or not. So as I come over here, I see that my value is 2. And what I need is a 1, right? So what I'll do is I will move my left pointer, and since I have to reduce value, so I'll come over here. And over here I see that the value that we got is a 1. So I know I have hit another condition over here wherein my triplet value is equals to 0. So this is how we can get it. So if you see over here, just as I mentioned, that you are doing a n work for all these n items. So we'll repeat for each one of this item, this entire operation, right? So what we'll have is a n log n plus order of n square. This will be the complexity. So what it will eventually mean is you will have a complexity of n square. And our brute force is having a complexity of n cube. And that is how we can get a better solution over here. So if you see that n cube is nowhere in the picture, it should be probably somewhere over here. So we can get this done in an n square, and we have order of n log n over here. So if we add, we generally take the higher of the two. So we'll take n square over here and we will accomplish the same, right? So yeah, this is how you should try to come up with the solution. You have to go with the step-by-step approach, and where we can optimize, right? So we have started with the single one, then we extended to a double, and then finally to a triplet, right? So what we'll quickly do is we'll move over to the Leetcode and try out the code. So to start with, we need to return this result. So let's create this array list over here, and we'll be returning at the end. So let's say this is our array list, and which we are going to return at the end. What we talked about in the solution is we are going to do a sorting of the array, right? So let's use some inbuilt class to get it sorted. So we'll use array.sort over here and get the num sorted. So this will give me a sorted list that we want to work with. Now we need to pick up individual elements and we need to perform the logic that we have talked about, right? So when should we check the duplicate? We should start checking the duplicate from the first index, right? The 0th index cannot be duplicated. It is the first index, right? And we have not seen any number prior to it. So that's why we are putting a check first that I should not be equal to 0. Then only we are going to check for the duplicate. And what we are going to check over here is that nums of I minus 1 and nums of I should not be same. If nums of I minus 1 is equals to nums of I, then basically we can say that we don't want to continue over here, right? So we'll continue the loop so that we don't go into any further processing. This is just a check where we are eliminating all the duplicates, right? And now what we need to find what we are searching for. So we are searching for a 0 minus nums of I, right? So I know that I need the sum 0 and nums I is taking this value. So this is the element that we'll be searching on that sliding window kind of approach, right? So what I'm going to do is, since it's a sliding window, minimizing sliding window, I can say. So I will take a left, which will point to your I plus 1. And I will take a right, which will point to your nums dot length minus 1, right? So over here, when I took this element for searching, so my left was over here and right was here, right? So right is always at the length of the array and it will be at the ith index plus 1. So it is true for all of them, right? That's what we are going to do over here. Right, and now what we are going to do is we are going into a loop over here while left is less than right. We are going to have this loop, and what we are going to do is we are going to check on the sum, right, every time. So nums left and nums right, we are going to add it. And if we see that sum is equals to what we are searching for, that is the point I know that I have found a result. So the moment we get a result, what we are going to do is we are going to our result array and we are going to put this. So what are we returning? We are returning a list only, right? So what I'll do is shortcut arrays as list, and we are going to put all of them over here. So the first number is nums I, then nums left, and nums right. These are the three numbers who has contributed to this triplet, right? That is all. We have few more things to do over here. I'll come to it in a little while. And then we have two adjustments to do, right? So if you remember, if sum is greater than what we are searching for, right? We already have a bigger number. We need shorter number. So we were reducing the right. We are moving the right. And otherwise, what we are doing, we have been moving the left. We have been incrementing the left, right? So either this or this, right? And if you have found sum, then it's fine. There is a chance that once we have this result, we might end up having a duplicate, right? So let's think of a scenario over here that you are trying to find a triplet over here, and you have an array like this. So what will eventually happen is you have picked up this and you're looking for a 0 and you got a 0, and now you move your left, again you got a result. So this is your result. This plus this your result, this plus, everything is your result, right? But if you remember what we have been given a constraint over here is that we cannot have these, right? Should not be equal. So we are going to remove the duplicates over here. So what we are going to do over here is to remove the duplicates using just a simple while loop, right? So basically for both the edges, right? So from this edge, what we are going to do is we are going to check, is my next number same as this, then remove it. Is my next number going to be same as this, then remove it. Again a loop which will, is my number going to be same as this, then remove it. We are going to have two loops which will remove the duplicate and take the pointers to a zone wherein we don't have the duplicates again, right? So we'll use a couple of loops over here which will eliminate the duplicate for the left edge and for the right edge. Left is less than right, the condition remains the same. The left should not overtake the right. So for both the cases, it should be the same, right? This is we are doing for the right. If I see this is same as my right minus 1, right? For right, what will happen is basically we are reducing index, right? So when I am checking, so basically when I'm checking for when my pointer is over here, I should check for this element, which is a right minus 1, right? And for the left, it should be left plus 1. So nums not equal, if nums equals to right minus, we are just going to reduce right, nothing else we are going to do. That's it. So the right will continuously move until it finds a unique number. And same thing we are going to do for the left as well. Left is equals to nums left plus 1. If we get the same value, then we are just going to increment our left. We have come to the edge over here, right? And now we have got the result. We are inside the if block. So this is just the adjustment of our left and right. So imagine a scenario over here. So I've taken a scenario over here wherein we are trying to find a triplet so that you understand why we are doing the adjustment, right? So what will happen as per our loop, we'll pick up this item and we will place 2 pointers in order to find a plus 1, which will eventually add up to a 0. So now what I see, my sum is a 3. So I have to reduce my sum, and in order to do so, what I have to do is I have to adjust my left. So I'll come over here. And I'll get a sum of 2 and minus 1, that is a 1. So now what has happened over here, I have found a triplet whose sum is a 0, right? So minus 1, and a 2 will give me a 0, right? But now the problem is they have said that we cannot have duplicates and neither have the same. So what will happen is if I try to find further, I will either increment my left or decrement my right, and I will still get the same number that we have got over here, right? And which is disallowed by the problem. What I have to do in this case, since my array is sorted and I know my left is pointed by a minus 1 over here and the right is pointed by a 2. So if I see my previous index is a 2, I am going to decrement my right. If I see the previous is still a 2, I decrement my right. Now I see the previous is not a 2, it's a 1. So it's different. So I'm not going to decrement here. Similarly, for the left edge, if I see my next index is also minus 1, so I'm going to increment. If I still see it is minus 1, I still increment. Now I see that it's no more a minus 1. So I know I have came to the edge of the values that I have found, right? That is minus 1, minus 1 and 2. And I know for sure this next value is a different value and his next value is also a different value, right? So these are the two while loops that we are using, right? That will bring me to the edge. So this will get me to the edge. And now once I am in the edge, or it could have happened that I was already in the edge, that these loops were never executed, right? So once this operation is done of getting me to the edge, what I need to do is I have to increment my left. So that will take me to the next unique value that I need, right? That is over here. And similarly, I will decrement my right, which will get me to the next unique index, right? So over here, you see that what I get is a sum, which is again a 1, right? So we have a 0 and a 1. But if you see here that we are not duplicating things, right? We are good. So these two while loops get me to the edge, and then we do a regulation plus and the minus of the pointers in order to get our intended result. So let's do the same into our code as well. So basically what we are going to do over here is to, after we have done the adjustment to our pointers, we are going to increment our left, which is a natural increment, and also decrement our right. So we move both the pointers and then we do the operations all over again. So we know that the left and right is no more standing on the value that has already been identified. So we are searching for something unique. So that we adhere to the condition that's been given over here, right? So let's run this code and see how it goes. As usual, I think there will be some errors. Yeah, I'm good at it. So it's arrays.sort and not array. Num start length -1. How goes? Yep, so you can see that it has been accepted, and let's do a submit and check for a broader range of test cases. So yeah, we have a submission of 18 millisecond, which is better than 86% of the submission, and which looks pretty fair to me. Which is pretty good. So if I talk about the code over here, the complexity part of it, then of course we talked about the complexity throughout our program over here. So the complexity that we'll end up having is this. This is our runtime. And coming to the space complexity, that we haven't consumed any extra space in this problem that we have solved. So we haven't created anything except for the result, which is needs to be returned. I cannot help on that. So considering that, what I'll say, we have a space complexity of order of 1. So yeah, this is optimized solution that one of the optimized solution that we might get. I have thought about this problem from a long time. So I was always thinking of having a better performance than order of n square, maybe n log n and order of n. Let's not talk about these two since the array is not sorted. I don't think it's at all possible to get a solution. Even order of n looks impossible to me, but I was wondering that if we can get an n log n. But I could not come up with a solution wherein we can solve this in n log n. What I felt was the best we can get is order of n square. So if you are aware of any solution which performs better than this, then please feel free to drop a note or drop a link about the solution, or post anything about it. I would be more than happy to know. So I hope this video was helpful. I try to make it as detailed as possible, going over the single, then double, then triplet, like how we can extend the problem in order to find the solution, right? The thought process about the same, how you should approach a problem when you get a problem like this, right? Wherein you have been asked to triplet. So don't think that every solution has order of n or order of log n complexity. We have different complexity. I know they're bad, but we need them. That's why they exist over here, right? We have seen n factorial as well in few other videos that we have done previously. So yeah, that's all from this video. Do let me know what you think about the solution. Do drop a note, do drop a comment what do you think about the solution. If you know any better solution, then please do let me know, and please feel free to share it with me as well. So yeah, do take care of yourself, stay home. The situation here in Bangalore is not very good. I pray that we all come out of this very soon. Stay at home, stay safe, take care of your family members. Don't stress out yourself much. Try to disconnect yourself and try to get some relaxing time as well. I know these are tough times, so just take care of yourself. So till then, see you.